so now we want to ask a couple more questions about this figure 2.6 that is at the bottom of page 64. By the way, this is a piecewise defined function. Here's how the function is defined. It's a good review of piecewise functions. Hopefully you remember what that means. All right, now here are the questions that I want to ask about it next. What is the limit as x approaches 2 from the left? What is the limit as x approaches 2 from the right? What is the limit as x approaches 2? What is f of 2? And then same questions for 3. All right, so take a moment to answer those questions. We have, 8 questions there? See if we can answer those 8 questions and then come back. All right, hopefully you're back with your answers, and hopefully you said that the limit as x approaches 2 from the left of f of x is 1. The limit as x approaches 2 from the right of f of x is 1. The limit as x approaches 2 of f of x is 1. But so as long as these two numbers are the same, then this one has to be the same as those, and it exists. And if these two are not the same, this doesn't exist. All right, so f of 2 is where the point is, not where the hole is. The limit is where the hole is. F of 2 is where the point is. So f of 2 we're going to say is 2. All right, now we're looking at when x equals 3. So now we're over here, we're looking at this part of the graph. Okay, so limit as x approaches 3 from the left of f of x. I hope you said that was 2. Limit as x approaches 3 from the right of f of x. That's also 2. And the limit as x approaches 3, since these two are the same, it's the same. And also f of 3 is 2. So in this case, all 4 of them are the same. All 4 values don't have to be the same. But if these two are the same, then these 3 have to be the same. So these 3 have to be the same. If they're different, then this doesn't exist. But it's special if these are all the same. So now we're also going to justify some of these statements. So you can not only say that limit as x approaches 2 of f of x equals 1, you can say the limit as x approaches 2 of f of x equals 1 because the limit as x approaches 2 from the left of f of x equals the limit as x approaches 2 from the right of f of x equals 1. Now this is a justification of this statement, and you're going to start to be expected to write justifications like that. So limit from the left, limit from the right, you don't have to justify. We would have to go to epsilon delta to do that. But once we can sort of take from the graph limit from the left and limit from the right, then we can use that as our justification for the limit being what it is, because the two limits from the left and right are the same. All right, so we can do the same thing here. We can say that the limit as x approaches 3 of f of x equals 2 because the limit as x approaches 3 from the left of f of x is equal to the limit as x approaches 3 from the right of f of x, and that happens to equal 2. All right, so this is a justification of this claim. All right, now this one where some of them were different is different from this one where they're all the same. So when all these values are the same, we can say something special about the function f. And what we're going to say is that f is continuous. So we're going to say f is continuous at x equals 3. And the justification for that is because the limit value is equal to the function value. So basically this idea of continuity, we're going to talk about it. What is a continuous function? But what it comes down to is sometimes the limit value and the function value are different. Sometimes the limit value and the function value are the same. If the limit value and the function value are the same, that's the definition of what we mean by a function being continuous at a specific point. So we're going to say f is continuous at x equals 3 because the limit as x approaches 3 of f of x is equal to f of 3, which happens to equal 2, because both of those things are equal to 2. All right, so the limit comes down to these two things being the same, or the limit, the continuity. Being continuous comes down to these two things being the same, and that's all you have to state for your justification. Now, in order for these two to be the same, these two happen to also have to be the same, because if these weren't the same, this wouldn't exist, and whatever this is, these had to be the same as. So when the function is continuous, all 4 things are going to be the same. But the only thing that is important in terms of continuity is these two, the limit and the function value. So f is continuous at x equals 3 because the limit as x approaches 3 is equal to f of 3, and that's what we call a continuous function. Now, by the way, we can go up here, speaking of continuity and justification, and at x equals 2, all of this is the same function f. This is y equals f of x, so everything's f. Okay, we can say f is not continuous at x equals 2 because the limit as x approaches 2 of f of x does not equal f of 2. All right? So if the limit is not equal to the function value, that justifies that f is not continuous. The limit is equal to the function value, that justifies that f is continuous. You'll be often asked, like on a test, one of my favorite test questions is, I will give you this question and I will say, the function f is continuous at x equals 3. Justify that statement. So I'm not asking you whether it's continuous or not. I'm telling you it's continuous. I'm asking you why. And that's the kind of thing that we're going to do a lot in this class. So I could look at x equals 2 and say the function f is not continuous at x equals 2. Justify this statement. He will say f is not continuous at 2 because the limit as x approaches 2 is 1, but f of 2 is 2, and they're not equal. All right? Now, this point is at x equals 1 is also not continuous, but we sort of didn't yet get to talk enough about continuity to say why. The short answer is because the limit doesn't exist. All right, but we'll come back to that later.